Hi, I'm Srinivasan from Team 17. We are Team Excelsior, and for this course, our term project is to develop a Unity game that can accept inputs from a LeapMotion. Here, the game is all about collecting gumballs and increasing the score, and we do have air pockets in the environment which is typically zero gravity zones where if you're gonna pass through, your score is gonna decrease. Typically you're gonna win the game by collecting more than 50 points. That's by collecting gumballs. You can either use the keyboard or the leap device to control your car. The car will be the main protagonist in this game. And the design patterns we implemented are factory method, adapter, observer, state and command, and each of my team members will be explaining each of their contribution in the scene.
Hi, I've implemented the factory method design pattern for instantiating different gumballs on the scene. Here's the class diagram for that. The product interface for gumball is a color gumball class. Red gumball and green gumball extend the color gumball class. And the class creator provides us with an abstract method called getGumball. Let's walk to the code for that. CreateGumball is a script attached to a game object which loads the scene. We use factory method of classes to create different gumballs. Our product interface, the color gumball, provides us with getter and setter methods for the material. Material is a component in Unity which renders the color in the object. Green gumball sets the appropriate material for grain color. And in the creator class, we have the abstract method getGumball. The factory method implements the getGumball and returns the material from the green gumball class. So, using the factory classes, we are able to instantiate different. We get different materials, and using that we can change we are able to instantiate different gumballs in the scene.
This is Nivedita. I have implemented the adapter pattern in our game. Our game can take input from two options, either keyboard or LeapMotion. So the car user control acts as a client. It calls the method in interface iAdapter move operation, which returns an float array and takes in an integer as a parameter. This interface is being implemented by input adapter, which has a keyboard adaptee instance and LeapMotion adaptee instance. These adaptee classes implement the interface iAdaptee, which has the method input move, which returns a float array. So then what happens here is, if the leap motion is enabled, the leap number passed is 1. Then the input move for LeapMotion adaptee is being called within the input adapter. If it's not being enabled, leap number has a default value of 0, and thus keyboard adaptee is being called, and keyboard is taken as the default input method. So we can move our car using LeapMotion to the left and right. When we collect the red checkered balls, we get 5 points each. And then when we collect the green gumballs, we get 10 points. When we move through the air pockets, we lose points. And then the blue gumball, which is 15 points. So we need to score 50 points to win. So once we reach 50, you win text the display.
Hi, I'm Srinivasan. My part was to explain or to implement observer pattern. The best part to implement this was in the car audio. So I made changes in the car audio and implemented the observer pattern there. This is the class diagram for the changes I made in the car audio. Let me show you the code. So in this code we have different methods that will be called when the car moves through the environment. For example, when the car has a low acceleration and a low reverse acceleration or the deceleration, it generates different sounds, and this has to be notified to the whole environment. This is where the observer pattern came into place. And when the car stops, we had a similar method. And when we had the update, like we need other sounds, like when it passes through the air pockets, or when it collects the gumballs, or when it skids through the environment. Let me show you the working prototype of the game with the car audio. So this is an acceleration sound, and this was the deceleration sound. This was the skid sound. And this was where the observer pattern was implemented. Thank you.
Hi, I'm Minerva, and today I'm going to explain my part in the game Gumballs Gone Wild. I implemented the state design pattern. It was used to implement the play, pause, and stop functionality in the game. So this pattern consists of a context manager. The context manager stores the current state of the game. It gets input as a key press from the keyboard, and it holds an enumerated list of the states possible. Next we have the game states class. So the game states class holds a boolean variable called paused, not paused being play, and it encapsulates the behavior associated with the classes that inherit from it, namely the play, stop, and timer class. The play class checks the appropriate state of the game and accordingly makes sure that you unpause the game. The stop class checks the state of the game and then makes sure that we can play the game subsequently. Finally, we have a timer class. The timer class measures users' activity in terms of the duration taken to play the game. The aim of the game being to minimize the amount of time by collecting maximum gumballs. So the following screen depicts the play pause functionality in the game. Upon a key press of P, the game pauses, as can be seen in the video. This is implemented by the state pattern. Again, if I press P, car starts moving. So that's how the state pattern implements play and pause and stop functionality.
Hi, my name is Soumya, and I implemented the command pattern for our game in Unity 3D. So this is the class diagram for the command pattern. Here we have a client who interacts with the menu. The menu is the program which connects with our Unity dashboard, and update is the function which loads when Unity 3D game is being played. So when a button is being clicked on our menu screen, the button the invoker button controller detects the button click and invokes the command iCommand interface, which in turn invokes the concrete command classes. Here we have two concrete command classes, concrete command load exit and concrete command load play game. These two concrete classes call the respective receiver classes, which finally executes the function load scene, which loads the respective scene for which the button has been clicked. So the overall flow is the invoker button controller is the class which invokes the function and which calls the iCommand interface for making the receiver classes execute the load scene functions. Thank you.
We have a Gumballs Gone Wild game, and there are a set of options which we can select from. Play game to load the card, instructions to view how to navigate through the game, and exit to close the game. So now we'll select play game. So we can move our car using LeapMotion to the left and right. When we collect the checker balls, we get 5 points each. And then when we collect the green gumballs, we get 10 points. When we move through the Arbor we need to score 50 points to win. So once we reach 50, you win the